Greetings, everyone, and welcome to SpaceWeek Live for this Sunday, January 9th, 2022. So, the big news of the week is, of course, if you have not already heard, that the James Webb Space Telescope is fully deployed. So, as we knew, or as I mentioned last week, there were two main phases of that mission that had everyone biting their fingernails. First was the launch on Christmas Day, and the second was the long and complicated series of deployments of the different parts of the telescope in preparation for its insertion into the halo orbit around L2 Lagrange point. So as of last Sunday, they had not yet begun the tensioning of the layers. So they had as of last Space Week, they had extended the forward, the aft, and the starboard and port, or left and right, booms, giving the Sunshield its diamond shape, but they had not yet separated the 5 layers of the Sunshield and tensioned them out. But they did that over the course of 2 days. They tensioned the first 3, and then they did the remaining 2 on the following day. Let me get that. It's kind of chilly in here. I have a space heater under my by my feet, but it's kind of loud. So that tensioning went as planned, no issues, and so those 5 Sunshield layers are completely deployed and tensioned. Now, the reason why there are 5 layers is because each successive layer absorbs some of the sun's infrared radiation and, reflects some of the sun's infrared radiation. And so the radiation that leaks through the first layer gets caught by the second layer. Anything that leaks through the second layer gets caught by the third, and so on and so forth. Now, they also have liquid nitrogen on board in the instrument itself, which keeps the instrumentation. It's going to, over the course of the next few months, it's going to continue to cool to a temperature not that not that high above absolute zero, but for now, it's fully deployed. So the secondary mirror is the curved or parabolic shaped mirror that extends out on the tripod in front of the large array of 18 hexagonal main mirrors, and it was fully deployed successfully. Okay, secondary mirror deployment complete. Then they extended the aft instrument radiator, which helps to dissipate heat on the rear side of the instrumentation part of the craft. And then the port or left side primary mirror was extended out. So when it was folded up in the for launch, the left and right wings of those three mirrors each were folded back, but the port primary mirror extended successfully. Okay, extension complete. Now the starboard or the right side mirror was extended or folded out, and once that was complete, the telescope was fully deployed. Now they still have a lot of work to do. Over the course of the next couple of weeks, before it arrives at its destination, they're going to individually adjust the 18 primary mirror segments and calibrate the instrumentation. And that's a multi-step complex process that's going to take, like I said, a couple of weeks to get the primary mirror all situated. And ultimately, once the L2 halo orbit insertion burn is done, 29 days after launch, let's see here, what's this? Mirror segment movements, that's what I'm describing. So that should be completed by about launch plus 27 days. And then the L2 insertion burn, there's a mid-course correction burn prior to L2 insertion at launch plus 26 days. And then by launch plus 29 days, they should be in their halo orbit around L2. Now, it's actually going to be a few months, up to 5 months, before they're ready to start collecting some images, because they have a very long process of allowing the instrumentation to cool, because it takes time. It takes time to radiate heat in space in a vacuum, and relying only upon black body radiation. And they also need to, again, calibrate the instrumentation and perform all sorts of tests to make sure that the telescope is ready to go prior to first light. So that process will take approximately 5 months. Good science takes time, and so we just have to be patient with it. So, in other news, last Thursday, SpaceX launched 49 more Starlink satellites into low Earth orbit, bringing the total number of Starlinks to 1,848.
T-minus 5, 4, 3, 2, 1. Lift off.
Stage 1 chamber pressure is nominal.
looking there at the black interstage between the first and second stages. It was a beautiful launch, and the landing was successful. If we fast forward to that, the footage was a little ratty, but that's pretty much normal. Getting clear footage of a booster landing is kind of an uncommon treat. We do get it occasionally, but most of the time the footage is pretty rough, as we see here.
And it looks like we have a live view of the drone ship.
Flag deploy. Stage 1 landing is prepared.
And we have touchdown of Falcon 9. And through the cheering, we also heard that call out for SECO 1, which is great news. Our booster landing today.
So, booster landing successful. Then last night, we had kind of a surprise launch that hadn't been very widely advertised beforehand, of a Black Brant 9 suborbital sounding rocket from the Mid-Atlantic Regional Spaceport, or MARS, on Wallops Island, Virginia. Wallops is a quieter spaceport. It doesn't see nearly as many launches as the Cape or Kennedy, but yeah, we got to see a suborbital launch. Now, on board was NASA's DXL experiment, or Diffuse X-rays from the Local Galaxy experiment. This was the fourth DXL launch, the first one being in 2012, where they confirmed that, so this experiment is to study what are called soft X-rays. These are low-energy X-ray photons, photons meaning they're a wavelength of light, just like visible light or gamma rays or radio waves. It's all photons at different wavelengths. But these are low-energy X-ray photons that are originating from two different sources. The first is from supernovae that are in our part of the galaxy, and the other is the sun itself through, let's see, what is it? Oxygen ion interaction with hydrogen atoms in space produces an X-ray photon when they interact, and the oxygen atom takes on a hydrogen. Whatever. I'm sorry. I saw a diagram of it, and it was really good, but I couldn't find it before the show. But basically, the oxygen atom and a hydrogen atom bump into each other in space, and what's produced is an ionized oxygen atom, and it releases a small amount of X-ray radiation. And so these are low-energy X-rays that don't pose any threat to life, but they do affect our ionosphere, and they can interfere with electronic equipment or the accuracy of GPS. So the Black Brant 9 is a two-stage solid-fueled suborbital rocket that has a max apogee of a couple hundred miles. It's pretty low firing, pretty low altitude sounding rocket. But nonetheless, that's all they need for this experiment. And it was interesting. Prior to the launch, they had it at an angle, a pretty steep angle, and then they raised it to almost vertical. Then they lowered it again. Then they raised it again. When it was in a angled kind of like that, they dropped what they called a belly band off of it. I guess it's some sort of a retention band that basically straps the rocket to the strongback or the launch rail during prior to launch, so that it's to give it stability, I guess. But the way it dropped off was just physically with a bag, like there was a weight hanging off of it. And they dropped the bag and the belly band just sort of fell off. It was interesting. And then the box that you see around the rocket there is, I think, just styrofoam insulation to insulate the rocket from the weather, basically. Because when the rocket took off, well, you'll see what happens to it. It gets utterly demolished. Let's check it out.
10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1.
And that's it. That's all we got to see. They had radar tracking of the rocket on its way up, but they did not have visual tracking. They didn't have a camera on it. Let's slow this down. We're probably not going to be able to see much, but let's slow this down and take a closer look.
1.
And it is gone. So solid fuel has a crazy thrust to weight ratio, and that boxy insulation around the rocket just didn't stand a chance. Anyway, so that was Black Brant 9. Looking ahead to, so that's actually it for last week. Around the holidays is typically a pretty quiet time for launches, and last week was no exception. There were just the 2 launches, and this week we have a couple as well. So looking ahead to this week, on Wednesday, January 12th at 5 p.m. Eastern, 2200 UTC, a Virgin Orbit air-launched Launcher 1 rocket will launch above the clouds, deploying multiple small satellites into a mid-inclination low Earth orbit. And this will include several space-based communications and in-space navigation satellites, a NASA-sponsored university satellites, and another Stork satellite for Polish satellite maker Sat Revolution, SteamSat 2 for the UK with water-fueled thrusters. So this launch was going to take place back in December, but it was delayed. But hopefully we'll get to see it this week. Then on January 13th, Thursday, at 10:25 a.m. Eastern, 1535 UTC, SpaceX will launch the Transporter 3 rideshare mission from Cape Canaveral into a sun-synchronous polar orbit. Sun-synchronous orbits are polar by nature, but not all polar orbits are sun-synchronous. So on board will be dozens of small satellites, microsatellites, nanosatellites, for commercial and government customers. And I was unable to find a manifest of what those satellites will be, but that's what will be on board. Now, here is a visualization of the trajectory for the Transporter 3 mission, which is really nice. Like you can rotate this, you can zoom in on it. Oh, look at that. They have okay. I just noticed they have the booster coming back to land rather than going out to a drone ship. So it looks like we'll have a land landing booster this time around. And I don't know where they get this detailed information from, but this is coming from flightclub.io. And they have not just the 3D visualization, but also, if I can get past get the interface to cooperate here. There we go. They have these graphs of the altitude over time, the flight profile, velocity, booster phase space, whatever that means, acceleration, aerodynamic pressure, a whole bunch of different parameters. So very detailed graphs here. Lots of fun for rocket nerds. And again, that site is flightclub.io. And then as far as telemetry, we've got some raw numbers here. But I just wanted to give them a shout out because that's it's really good info to have beforehand. You know, plus especially with the 3D visualization, you can see whether the flight is going to be on a trajectory that you can see from your location. Obviously, this one is heading south, so me up in North Carolina won't be able to see it. Okay, so let's see. I'd like to take a moment to thank and welcome our newest channel members. Sneeuw Poesjes, if I pronounced that correctly, I'm sorry, Dutch does not roll off my American tongue. Snow Kittens, our good friend and moderator, has become a member, so thank you. As well as Major Tom. Ground Control would like to extend its hearty thanks. So thank you to you both. And let's see. Wanted to take a moment, so I don't know if you remember, I think it was 3 episodes ago, I mentioned my book of really bad dad jokes, or exceptionally bad dad jokes. I wanted to say another couple jokes because what is life if not for the opportunity to do a little cringing? So how would you find Will Smith if he was hiding in the snow? You follow the fresh prints. And that's all the reaction you're going to get from me. Some of these I do crack up on, but let's see. I've been listening to Queen's, so following the musical theme, I've been listening to Queen's album for the last 13 hours. I feel rather ill. It must be the high mercury content. So, kind of a science-y one there. So those are the dad jokes of the week. Now, your questions. All right, right off the bat, I see that Deal Ike just asked, will the Transporter 3 launch be visible from eastern North Carolina? I doubt it because it's heading on a southerly trajectory. It's launching to the south and away from us, so I don't think it will. But all right. So questions. Let's see what you got. Rockin' Robbins 13 says, so how much cooling is left to do with liquid nitrogen over and above the cooling accomplished by the sunshade? That's a good question. I don't have the technical specifications of James Webb handy. Like, for example, I don't know how much, I mean, I could try to look it up, but I'm not sure how much liquid nitrogen they have on board and what I mean, it's expected that James Webb will last for at least 10 years. I don't know if the liquid nitrogen will be lasting that whole time or what. Because over the course of time, you know, temperature tends to equalize. So, so I really couldn't answer that question. But let's see. The current, okay, so I tell you what, let me go to NASA's Where is Webb page, Where is Webb webpage. And so on the hot side, it's, okay, so this is in Fahrenheit. On the hot side, it's 131 Fahrenheit, which is, you know, Arizona temperatures. And that is the, let's see, A is the Sunshield, and then B is the spacecraft equipment panel. The spacecraft bus is only 51 Fahrenheit, so slightly under room temperature. on the hot side, which is pretty cold actually. But on the cold side, we've got the primary mirror, which is the large array of 18 hexagonal mirror segments, is negative 289 Fahrenheit, which is negative 178 Celsius, and the instrument radiator temperature, or the actual instrumentation in the guts of the telescope where the liquid nitrogen will be cooling, is negative 328 Fahrenheit, or negative 200 Celsius, which is quite cold. And let's see, absolute zero in C. Absolute zero is negative 273 Celsius, 0.15. So currently the instrumentation on James Webb is 75 degrees Celsius above absolute zero, which is pretty darn cold. MVM Motovlog Music asks, what do you figure the first JWST images will be? Well, they have considered that question, they being the NASA and the people operating the telescope, have considered that question very carefully, and they're not telling us. They have a variety of targets that they're going to focus on. I mean, you know, literally focus on, but also they're going to go after first. And you know, it's anybody's guess as to what they are, but you know, I've heard a lot of mention of the Hubble Deep Field, or the Ultra Deep Field, and the Pillars of Creation, which is a very aesthetically popular target and supposedly a good target for infrared. But you know, those would probably be my guesses for amongst the first things they might look at. They might also point it toward the core of the galaxy, toward the center of the Milky Way. It'd be interesting to, because one of the biggest hindrances to seeing the center of our own galaxy is all of the dust that's in the way. Well, infrared is very good at cutting through dust. So I would guess that they might get some image sequences of the stars in the center of the Milky Way orbiting the what we know to be the black hole at the center thereof. Sir Geoffrey Claude says, this commentary is so polished and spot on, I'd like to ask your background in education. Well, first of all, thank you. Those are very kind words. My background is, I mean, by profession, I'm a software developer. And I was in the Air Force before that. But my education is in information technology. So, I mean, I would like to take some astronomy-related classes, maybe not astrophysics. I think that would make my brain explode. But I would like to take some formal classes to learn more about this topic that I care so much about. But you know, that just that just hasn't come about. I mean, classes are expensive, and life happens. So in the meantime, you know, whatever little amount of information I know, I try to pass it along, and I've just gathered that from being curious, asking questions, and seeking out answers to not only my own questions, but the questions that other people ask, because I'm like, oh yeah, that's a good question. Let's look it up. It's sometimes a little bit awkward if I look up the answers to questions during a live stream, because it's like, please wait while I Google this, tap, tap, tap. But, you know, one way or the other, the answers, most of them are out there. And they just await our interest and time to look them up. Let's see. Going back to the live chat. Scanning for questions. Astro Zeus is taking an astrophysics class right now. That makes his brain hurt. Yeah, I've seen some of the mathematical aspects of what was it? Hydrothermodynamics or something along those lines. There's some sort of aeronautical equations, and I was like, holy cow, geez Louise. I mean, calculus was enough for me. I don't think I could handle much more. I don't know. Maybe I could. Maybe I could stretch myself and discover some new capacity for that sort of thing. But okay, so Deal Ike asks, can you explain soft X-rays? So whether X-rays are considered soft or hard is based on their energy level. So hard X-rays are higher energy. Those are what you get blasted with at the doctor's office. Soft X-rays are lower energy, like, for example, when that solar oxygen atom bumps into the hydrogen atom and produces an ion and emits a little photon of X-ray. It's a much lower energy level of X-ray photon or light, you could consider it. And so these aren't the sort of X-rays that are going to cook you or sterilize you, but they do affect our ionosphere. I don't have a lot of detail of soft X-rays. I'm neither a radiologist nor a solar wind expert, but if you look them up, I'm sure there's a wealth of information on Wikipedia and elsewhere. It's got to be a curious topic that would be fun to learn some more about. Morrigan E. Wolf asks, just curious, is that a 3090 in your rig? So I have a very long USB and DisplayPort cables going from my computer monitors, which are in front of me. Look, it's like 3D. My computer monitors, which are in front of me, back to my computer, which is behind me. So they're going around the room. I did that a few weeks ago, and because I figured my computer looks nice, so why not display it during the stream? And no, it's not a 3090. It's an EVGA GeForce RTX 2080 Ti. So the sort of previous generation Big Daddy video card. I got that one specifically because it had the most video RAM of any other sort of reasonably priced. I mean, they're still overpriced, but sort of reasonably priced video card. It's got 11 gigs of VRAM, and it gets the job done. It's not the current generation though, because this build is almost 2 years old now. Miss AG asks, how long have you done this for? Well, the channel was I first created the channel in early 2017, and it was just a place where I would dump Apollo videos, from Apollo 11. And then there were a few months of time when I didn't really even visit the channel. I kind of forgot about it. But then I went back and checked it out and discovered that there were a couple of the Apollo videos that were actually quite popular and had a couple 100,000 views, particularly the television broadcast of the Apollo 11 launch. And I was like, oh, wow, I didn't know I had all these. And at that time I had, I think, 900 subscribers or something, which I was like, wow, I didn't even do anything. So I realized at that point that there was an interest in this stuff. And so I was like, well, what can I do? And then the following year, 2018, is when I started live streaming. First, I started with, well, my very first live stream was a lunar eclipse. Was it a lunar? Yeah, it was a lunar eclipse. And followed by the Parker Solar Probe launch. And I've been live streaming ever since. And then SpaceWeek started in 2019. I think it was November 2019 was the first SpaceWeek episode. And now here we are, episode 103. At first it was an edited video, it wasn't live, but then I was spending something like 15 hours every Sunday editing this video, and I got burnt out on it. So I was like, well, I want to provide a Space Week, but I can't spend all day working on it because I just don't have the energy, being a single dad and having work and everything. So I switched to the live format, which is where we remain today. Geraldine Braun, nice ambiance, lighting, thank you. I've got RGB lights around the periphery of my ceiling, and I like the purple color, so there you go. I can switch up the color, but I like purple, so there you go. As you may tell from the color of Nebula behind me, which is the name of my computer. All right. Let's see. Mark Desire says he lives on the other side of the Earth. Sort of. I mean, you're only, 6 time zones ahead of me, over in the Netherlands. All right, so let's see. Hold on, let me make sure I'm not missing anything. Okay, so I did want to take a moment to do a little rant. This isn't maybe what I want to end on, but there's something I just noticed which really kind of irked me. And I was searching for, I don't even know what I was searching for, but I stumbled upon a stream from a channel called SpaceX. Not SpaceX, but Space with a space X. The number of subscribers is not visible. The stream was called SpaceX launched Starlink SATS mission. Elon Musk gives update on SpaceX. And at the time, now it looks like there's only one watching now, but at the time it was registering 1,900 concurrent viewers. And I was like, holy cow, what is this? And so I clicked on the channel, and first of all, in the stream, oopsie, oh boy. In the stream, okay, looks like it ended. You couldn't view back. Like, it had only started like 30 minutes previous, and you couldn't track back to view anything, so you couldn't see what you had missed. But so I clicked on the channel, and there was only one video, the live stream. Go to the About page, there's nothing there. Channel created December 4th, 2020. So I tried typing in SpaceX on Social Blade, which is a website that tells you about YouTube channels, and I didn't get anything, but I typed in the channel code, like the long alphanumeric code for the channel, and it revealed that the channel used to be called Gerrit Craft, G-E-R-E-T Craft. It's based in Russia, and it has around 6,000 subscribers. What ticked me off was that they were blatantly trying to spoof SpaceX, and they had 1,700 of what I presume to be bots viewing the stream, artificially inflating the view counts. And like, I saw that the stream had, I don't know, like 20,000 upvotes or something. But I don't know. I know scammers are going to scam, but it just ticks me off that legitimate channels, they try so hard to provide compelling content and to gather viewers while, scammers are able to game the system and artificially inflate their numbers. Well, hopefully they get shut down permanently because that is, of course, against the terms of service. But YouTube has millions of channels to deal with. So anyway, I'm also dealing with a false copyright claim at the moment. So, but I wanted to take another moment to invite you to check out, let's see, let me go to my own page. Go full screen, and here we go. All right. Wanted to invite you to go to my page and check out my 24/7 satellite time-lapse Earth views stream. This is, if you didn't catch my introduction to this stream, it's sort of been a labor of love of mine for the past 2 years or more, collecting ultra-high resolution, like 11,000 pixel size satellite images of Earth from multiple satellites, from NASA and the Japanese Space Agency and the Russian Space Agency. And so I collect these images and then render them into very beautiful and detailed time lapses. And then I apply artificial intelligence slow motion processing to the videos to slow them down even more so that they are smoother. And so this is what we're seeing here. This is just one view. There's multiple views. There's one from like right over South America. There's a zoom-in view of the United States. There's one over the Australia and the Pacific. And so yeah, I'll continue streaming this because I think it's a unique view that you're not going to see anywhere else because no one else has taken the time to gather these 14 plus terabytes of satellite images to render these things. And when I am able, I do plan to upgrade the stream to 4K. Currently it's 1080p, but my streaming rig wasn't up to the task of streaming in 4K. But once I get upgraded, I will be bumping up the stream to 4K so that you can, if you have a 4K screen, you can view it in that resolution. But in any case, little plug for my own stream there. Let's see, Rockin' Robbins 13 says, how about Europe's Meteosat images? They have 2 satellites, So if I can, thank you for the link there, Snow Kittens. If I can find a source for the high-resolution original images from Meteosat, then I would definitely be interested in adding those to my collection. I might need to buy some more hard drives, though. Oh, and I have good news regarding this stream. Oh, wait, let me rewind this. This is amazing. Watch this. Watch this. Okay. All right, you see that right there? What you're seeing, this is serendipitous timing. What you're seeing there is a total solar eclipse zooming, the shadow of the moon zooming across the Pacific Ocean. This was in December of 2020, and this was the South American eclipse, the Chilean and Argentinian eclipse. So here, let's look at it again. And I actually have this eclipse in 2 different views. There's this one, which is focused over the Pacific, and I also have the same eclipse visible from the goes east, which is directly over South America. But it's just an incredible example of the sorts of things that you can see from the perspective of orbit that you can't see with the same, with the same perspective from down here on Earth. But Yeah, some coincidental timing there. But anyway, Rockin' Robbins, if I can find a source for those Meteosat images, I would love to add them to my collection. And if... Let's see. What's the purpose of the black bar? Black bar? Not sure what you mean. Perhaps you could clarify offline. But all right, so that looks like it's going to wrap it up for this week. Thank you all for coming. And I hope to see you in the next live stream, which should be... Let's see. I forgot my own schedule. Next live stream is going to be Launcher 1 on Wednesday. So until then, I will catch you later. Keep it raw, and bye-bye for now.